I think we are all set to go. So
Okay, you can probably go whenever.
Okay, awesome. Well, thank you guys for having me. My name is Becky Schultz, Rebecca, if that suits anyone as well, because that's on all of my slides. So I'm going to share, I think, hopefully we'll do this right, Pete. Okay, so this should be the presentation mode that you're seeing, right, Pete?
We see you.
Momentarily,
We see
yeah.
you.
It'll come up in a minute, I'm guessing.
Oh, yeah.
Okay,
There
yep,
you
you're
go.
okay.
Great.
Okay, awesome. So the title of my talk today is The Flight Path of a Career in Aviation Meteorology, and this is for the UW-AOS Alumni Career Seminar. So I always like to start with an outline of what I'm going to talk about. So I'll give you a brief introduction and quickly talk about my undergraduate career at UW. Then I'll go into my experience at Southwest Airlines on their meteorology team. And then I'll quickly talk about my graduate school career at UW as well. And then talk to you about my current position with AvMet applications and how federal contracting works in the meteorology world. And then finish with some closing remarks. And at any time, if you have any questions, I don't mind being interrupted at all. So better to ask them when they come to your mind. So a brief introduction of me. Obviously, my name is Rebecca Schultz. I'm from Franklin, Wisconsin. I'm currently living in Washington, D.C., and my current job is an associate scientist. And obviously, I'm speaking to you today because I'm a University of Wisconsin alum. I got my bachelor's from UW in 2015 in AOS with a certificate in environmental studies, and then my master's 2 years later in 2017, also in AOS, and I had a coursework emphasis there on energy analysis and policy. So to quickly recap my undergraduate career at UW, I enrolled in the fall of 2011, which is sad because that was a very long time ago now. As an intended AOS major, I was one of the lucky ones that knew right away that I was going to be AOS, as I'm sure some of you did as well. And my senior research in undergrad was on numerical weather prediction, compiling our own version of the WRF model with Dr. Michael Morgan. We had a group of about 5 of us in undergrad doing that together. As I mentioned, I did a certificate in environmental studies, and I was also an officer of the UW-AOS chapter, which you're all familiar with now since this is your first meeting. And then in terms of internships, the summer after my sophomore year, I did an internship with WISN 12 News in Milwaukee. I actually came into AOS thinking that broadcast was going to be my career path. So I was really excited to do that. It was a great experience, learned that it wasn't for me. And then the summer after my junior year, I was a student volunteer at the National Weather Service office up in La Crosse. So immediately after graduating with my bachelor's, actually the next day I got in the car and I drove to Dallas, Texas for an internship in the Southwest Airlines meteorology team. I kind of applied on a whim on a day senior year where I just maybe wasn't thinking I super wanted to go to grad school, and applied on a whim and then ended up getting it. I was really, really lucky to get this internship and headed down to Dallas. So I always start with this picture of the Network Operations Center in Dallas because this room actually looks like that all the time. They use this blue lighting in the control center so that it's supposed to be good on your eyes if you're looking at computer monitors all day. And you can see all the different desks here. It felt like a casino floor, and instead of slot machines, they were dispatchers' desks. It was just a really awesome place to work. But it is the living, breathing, functioning brain of Southwest as an airline, and it was just really awesome to be at the epicenter of everything that was going on every day. So that internship started in May, and then it ended up getting extended through December. They, in a weird turn of events, they didn't have a fall intern lined up, and I was asked to stay, and I couldn't turn that down, even though it meant postponing grad school for 1 semester. So I got to do an extended internship, which was so rewarding and awesome that I got to do that. So the main tasks of my daily life as an intern at Southwest was to assist with their forecasting for 4 major stations. They issued a forecast in the morning and then in the afternoon for Atlanta, Baltimore, Denver, and Chicago Midway. And those still are their big 4 airports. And then also I helped to create system-wide forecast maps and risk analysis graphics that covered the entire system. And this would range from daily graphics to who was anticipating any severe weather or any really major weather impacts, varied from that to even special scenarios like hurricane briefings or severe weather outbreaks when we would put out advisories for things like that. And then I think the coolest part of my internship is that twice a day, a core group gets together in what they actually call it the situation room. And that's in the heart of that NOC room that I showed you on the slide prior. And the people that attend this meeting are key stakeholders in the NOC. So that ranges from network directors to chiefs of dispatch to flight scheduling and flight planning to crew scheduling, pilots and flight attendants, as well as social media stakeholders would be in that room too. So it was kind of like a healthy mix of everyone who was in these meetings twice per day that was crucial to the operation. So those meetings always start with a weather briefing. It ranged from 3 to 5 minutes, say, at the beginning of every briefing meeting, and it would just really cover what we were expecting across the entire system. And obviously, as you can imagine, some days were pretty quiet and some days were not so quiet because you're covering the entire continental U.S. So some of your briefings were really short and some were pretty long. But in the summer portion of my internship, I was just observing those and sometimes assisting with putting the briefing together. But towards the end, I was actually presenting them. And I have to tell you, that was one of the scariest days. I think it was my first weather brief, but you got the hang of it pretty quickly. And it was just awesome to be able to sit in that room and tell all these head honchos at Southwest what the weather was going to look like that day. So on the bottom right there is a really awkward picture of me in that situation room. In the middle is where you would sit if you were giving that briefing. So you can see the NOC is behind those windows. And then you can see the 4 monitors. These were on all over the floor at all times of the day, displaying flight information on some, and then you can see there was a radar picture there too. And then on the far left bottom picture is actually someone giving the weather briefing in the portion of that daily briefing meeting. So you can see they have a radar product up there from CWIS that's developed from MIT Lincoln Labs is that product. And I did want to mention, unfortunately, all of Southwest's products and forecasts are proprietary. So I don't have access to them anymore, obviously, and I also would not be able to share them with you. They're internal to Southwest. So I would love to show you some of the actual maps I was creating and some of the stuff we actually presented, but unfortunately, I do not have that ability. And then just to give you a little bit of background about the meteorology team, it has obviously evolved since I've been there 3 years ago, but as of April, they consisted of 10 meteorologists. That was up from, I think there were 6 when I started, so that's really awesome growth in operational meteorology that I'm not sure we always see across the industry, so it's awesome to see that. They did just extend their coverage and in terms of their job shifts, they did extend to 24 hours. So I'm not sure if they're loving it, but that means a midnight shift was put in place. I think it was 11 p.m. to 7 a.m. is that midnight shift that they added. And then as an airline, they're one of 2 to have their own meteorology team. When I mention major airlines, I'm talking about the big 4, so United, American, Delta, and Southwest. So Southwest and Delta do have their own meteorology teams. Delta is based in Atlanta. However, United and American outsource their meteorology support to the weather company, which is based up in the Boston area. And then lastly, the meteorology team has achieved full EWIN certification. So what that means, I'm not sure if any of you are familiar with TAFs or terminal aerodrome forecasts, but they are able to write their own, which is really crucial. In the past, you rely on the weather service offices to write these forecasts for each airport, and you're bound to what the weather service says, whether or not you agree with it. So having the ability to write your own is really awesome and important in the commercial airline sector. So speaking of TAFs, that's a great segue into my next slide here. Just some of the major challenges in aviation forecasting. I've listed here the first being ceilings and visibility. So ceilings are the lowest cloud layer. So obviously when you have low ceilings, you have a cloud layer that's pretty close to the surface, and that's really detrimental to flying. It's really hard to land on a runway with really low cloud deck. And then visibility, pretty straightforward there. Turbulence is also a huge challenge. I'm sure everyone is familiar with turbulence if you've ever flown before, really, but they do get a lot of flight attendant injuries due to turbulence, and in some cases we would have to go back and do a case study on a certain event. So it's a big challenge to forecast turbulence. Convection is probably the most widely forecast parameter, but it's very important to airlines because obviously you can't fly through a thunderstorm, and then also the duration of convective season. I mean, it starts now towards the end of March and can last all the way into fall as well. So it takes up a big chunk of their heavily trafficked, I mean, summer is the most popular time to fly, so it's very important that convective forecasts are relayed with as much accuracy as possible to these airlines. And what they care about most is timing and then also intensity. So they want to know when the storms will start, when they're going to end, and how bad they're going to be. And they care about if the storms are lined up in a linear shape, so if it's like almost a frontal system moving through, or if they're more popcorn convection. It really helps for them in planning the routes that each aircraft is going to take around convection. And then winter weather, obviously being from Wisconsin, I'm familiar with this, but the time that I spent at Southwest actually did not involve any big winter storms. So I was kind of sad to not be able to see how the operation would respond, but I'm sure you all have seen news segments when big winter storms hit and airline passengers are stranded and hundreds, if not thousands, of flights are canceled. So winter weather has a huge impact on the airline operation. And what they really care about is precipitation type. So obviously the 32-degree line really matters if you're going to have freezing precipitation or snow, and then duration. They want to know how long they're going to be on the ground and when they can start flying again. So I think just the most important part for me as an intern that I had to learn was how to really be able to be fluent in reading TAFs and METARs. So METARs, apologies for those who have had these in classes, and this is really straightforward for you, but just in a general sense, on the left there is a report of METARs. So this is, the top line is the most current, and then the bottom, usually roughly every hour or so. But I actually grabbed this one from Des Moines earlier this week because I thought it was a great example of having a lot of information in it. But on the far left, KDSM is the station identifier. And then you move into the date and time, the wind speed and direction, and then visibility and the precip type, if any. So you can see in that pink circle that I have there, it goes down to 1/4 of a statute mile visibility, which is really not what you want in aviation because it's very hard to land a plane when you can only see 1/4 of a mile in front of you. And then you can see the fog. FG there stood for fog. So this is just an example of, I think they have over 100 airports. So I was reading these METARs as if it was just another language at the end of it. So that was really important to know the information contained there. And then the bottom right is a TAF, which usually follows right after the METARs. So if the METARs are looking back in time, the TAF is the forecast looking forward in time. And again, you start with the station identifier. So this one was from Chicago Midway. And then again, date and time, and then this will, it'll start to tell you what time this forecast is valid to. So for example, this was September 19th from 15Z to September 20th till 18Z. So the pink circle that I put on this TAF was just saying, to me, because this is something that they would have picked up on at Southwest and wanted to pay attention to, as the 30% probability of thunderstorms and rain. So just things like this, there was never a day where there wasn't something interesting in a METAR or a TAF, so that's kind of what kept it exciting, but really important to learn how to read those. I was just going to quickly step through some of the forecast tools that we would use to help make forecasts both for those 4 stations that I mentioned and then also for the entire system. We usually looked a lot at the National Weather Service tabular forecasts, and these were for each airport. So you can see in the black at the top is the date and time, and then the left column in each of the colors is a different parameter. We would also look at the GFS MOS LAMP guidance. This is just another table-like format, and at the top is time, and then again there's so many parameters on the left here. One of the most important ones though when looking at the LAMP guidance was the ceilings and visibility forecast. We also would look at the I'm sorry, something's in the way of my computer. The extended convective forecast product, ECFP. This is put out from the Aviation Weather Center in Kansas City, so this was crucial to make sure that we were on the same page and seeing the same things that they were. I'm sure most of you have seen a map like this at some point. This is the Storm Prediction Center's convective outlook. I think now these go out to 7 days in advance, but for the forecasting we were doing, day 1 and day 2 were really crucial to our forecasts. And then Weather Prediction Center's surface fronts. This really helped in the transition when I was there from fall into winter weather, because it helps to be able to graphically see where you're seeing precipitation change, like with the blues and the purples over Wisconsin and Illinois in this particular map. And then, of course, every day we were looking at forecast models. This is just a screenshot from WeatherBell. It's not freely available. I think it's like $100 a year, maybe subscription, but it houses all the models, and that's what we used at Southwest. So just to summarize, some major takeaways from commercial aviation. I might have touched on some of these before, but it's really important to remember that decision-making for us was never up to the meteorologist. And sometimes that was frustrating, and other times that took pressure off. But the information that we were providing, be it forecasts, analyses, products, etc., these were provided as support only, and they're factored into decisions, but they do not provide the actual decision that will be made. So, for example, if they were looking at canceling a bunch of flights due to winter weather, what we're providing as a forecast is really only guidance for that decision. We are not the one, or I say, we were not the ones making the call to cancel flights. And ultimately, these decisions are left up to airline dispatchers, network directors, and then sometimes it's even outside of the airline's hands if air traffic control puts out decisions as well. And I also found that operational forecasting was very humbling and also rewarding at times too, but no forecaster is ever going to be batting 1,000, and no forecaster will ever put out the perfect forecast every time. It was important to remember when I was doing these, and they felt really important at times. I mean, there were a couple of hurricanes that season when I thought, I just don't know if I have the confidence to be putting out a forecast or something that's going to have this big of an impact. It's important to remember that credibility builds over time. So that was a nice reminder sometimes that no one is ever going to fire you or think that you're a horrible forecaster because you missed the mark one time. And everyone reading a weather forecast knows that it comes with a certain level of confidence. So that sums up my time at Southwest. That's a good time for a break if anyone had any questions about Southwest at all. Otherwise, I can keep trucking on. Okay, I'll take silence as good. So I'll keep going. So then just briefly touching on school at UW, I mentioned that I deferred for a semester in order to stay at Southwest. So I actually enrolled in the spring of 2016 as a master's student. I was lucky to be a graduate research assistant. My master's thesis was titled Advancing Hyperspectral Sounder Applications and Analysis of Pyrocumulonimbus Events. And my advisors were Dr. Elizabeth Weiss, downstairs in Sims, and then Dr. Michael Morgan. So again, I mentioned that I put a coursework emphasis on energy analysis and policy. Unfortunately, because I did my master's in 3 semesters instead of 4, I didn't have the time to complete the actual EAP certificate. And that's something that I wish I could have done, but it was nice to get that coursework and broaden my horizons into the energy sector a little bit as well. And then lastly, I was the facilitator of the Graduate Student Association at AOS. So here are a couple pictures of posters that I presented at conferences, and I just want to make a side note here, because I am someone that did both undergrad and grad school at the same program. I'm always open and willing and ready to answer anyone's questions or concerns about grad school. If it's ever a decision you worry about making, it was a really, really tough decision for me personally to make that I just didn't know if I wanted to go or not. And I ended up finding that getting a master's degree was extremely beneficial for me personally. So I'm totally open if anyone wants to talk offline about grad school questions or what it was like transitioning from undergrad to grad school. Okay, so then moving on into my current position, I've mentioned I work at AvMet Applications as an associate scientist. A little bit of background just about my company. We're an aviation consulting firm that was founded in the year 2000, headquartered in Reston, Virginia, which is about 30 miles west of downtown DC, but we also have a satellite office downtown in the city. We specialize in aviation meteorology, obviously, given our title, but we also provide expertise in program management, system engineering, program analysis, and then research and development as well. And we are a prime contractor for the FAA, or Federal Aviation Administration's Office of Next Gen, which is abbreviated by ANG. So that is our main customer. And some of my main job functions are to provide technical support to the policy and requirement service branch of ANG. So that's titled ANG C6, which of course means nothing to anyone outside the FAA, but technical support can range anywhere from meeting support, taking meeting minutes or setting up meetings, or coordinating people's topics that they want to discuss, to ad hoc research requests, or providing subject matter expertise. It's really a whole gamut of support that we're providing as meteorology support to ANG C6. The other half, I guess I would say, of my job is conducting research, and these are for various projects that are funded by organizations like NOAA, NASA, MIT, Lincoln Labs, UCAR, commercial airlines. Our company has a really expansive portfolio of agencies that we have been funded by, so that's really cool too. And with that research, part of my job is also to write reports and proposals to propose new research projects and keep that cycle going. Some of the most enjoyable aspects of my job is the interaction between different agencies. For example, just this morning I was up in Silver Spring, Maryland at the National Weather Service headquarters, and I personally was facilitating a meeting between the National Weather Service Aviation Weather Division and the FAA's Aviation Weather Division as well. So it's so, to me, it is so like enriching to be able to sit in a room with all of these people and see the inner workings of this interagency operation, really. And to be able to hear some of the projects they're working on and their partnerships and where that all falls in place. So that's really cool. I also really enjoy having the ability to work independently, but also serve on a team. And I personally enjoy that my job is more focused on research and not operations. I think when I say that, I mostly mean I'm very grateful to work a 9-to-5 normal shift job instead of operational shift work where I'm working nights and weekends and holidays. So I'm very grateful to not be in operations, but that doesn't mean I didn't enjoy my time in operations as well. I just prefer this lifestyle. So I'll quickly step through some of the interesting projects that I'm working on. When I first got to my company, the first project I was handed was called wind compression. And I thought, oh, well, this will be a slam dunk. I just got my master's in meteorology. I know what wind is. But it was really cool for me to learn the aviation piece of this. Wind shear, as some of you may or may not know, is the change of wind, both the speed or the direction, as a function of altitude. So winds behaving differently at the surface than they might aloft. So I knew what shear was, but it was cool to learn that when you combine severe wind shear with heavy air traffic, you can create a situation where these, and you can see it on the left, that red circle on the left is where these airplanes become really compressed, essentially. So I thought of it, it was explained to me as driving on the freeway and someone slams on their brakes and now all the space that you had between the car and in front of you minimizes drastically. So it's essentially like that just happening up in the air. So that's a huge issue, a huge safety concern, but it's important to note that this event doesn't happen unless you have the volume. And that took a long time for me to understand that I knew the weather phenomena was there, but I had to bring in the aviation piece that you have to have the aircraft in order for it to matter. So the analysis that we did included looking at the timing and the duration, the location, airports, and altitudes of these events. And we also ended up doing wind climatology using various forecast models. And eventually this led to me developing a concept of integration for wind compression events and that type of information being integrated into operations. So it was, I thought, a great segue for me as a first project coming in. And then the next project I worked on was we refer to as airborne operations. So this map here is plotting all of the aircraft that carry a particular sensor that allows an observation to come in from that plane. So not all planes carry it, but a lot do. And so we were looking at where the coverage was of these planes that were flying with these sensors. So you can imagine many different parameters come into play here. We looked at this information by season, by time of day, by airline, because some airlines would have a particular type of airplane carry the sensor and others not, or some airlines would participate and some didn't. We also looked at altitude. So you can imagine you don't have very many observations at the surface because planes fly in the air. So it's sort of things like that where you had to look at many different parameters went into this analysis. So this is just one screen grab. I think this was about 25,000 feet that we're looking at. And you can see we identified different gaps in coverage here over Western Canada, the Northeast Corridor, the Southwest United States, and then an area in Mexico as well. So this was just identifying gaps and seeing where the value was if we were to add airborne observations in these regions. And another project we looked at was called Similar Weather for Rerouting. So my company has an amazing tool called Similar Weather Toolkit, SWT. So what that does is essentially if we were to know where we were expecting storms or convection, then we had the capability of looking up days in the past that had similar patterns of weather. So this example here on the left, we were expecting storms in the southeast. So we looked for similar weather days where we had the same timing and the same pattern of convection. And you can see we found one that was pretty well correlated to what we were expecting. So then what we can do once we have that information is look at they're called reroutes, when you have to essentially reroute your plane if you're flying around convection. So we were able to find specific reroutes that were used on those days in the past so that controllers could get a heads up and say, well, we've had this day before, it looked like this, and this is how we handled it. Maybe we learned from that, or maybe we don't want to repeat that day. So it was able to give them some guidance into how they would handle convection. And this was a project that we only do during convective season, so it obviously goes dormant in mid-October and comes back alive in March. Next, I can step through these pretty quickly. We're just looking at where, if you have stations where you're collecting METARs and surface observations, but some of that information isn't being reported, how do you interpolate to fill in that missing information? So we had stations here in the Gulf on the left here that we found clusters of 3, and we were looking at how best to kind of fill in the gaps for missing information using nearby stations. So that included weighting of the distance between the stations and the information provided. So that was in the Gulf of Mexico. And then we also did the same type of analysis in the Caribbean. And this was actually work that was requested by JetBlue. They hired the weather company, and the weather company said, we have an algorithm. Here's what we're going to do for missing information. So then that was handed to the FAA to be approved. So our piece in this puzzle was not the analysis part, but the validation part. So we were able to look at the likelihood and the severity of these forecasts falling within regulations and within the range of what an actual surface observation would be. So of course, I'm giving a very high level overview. If anyone wants more detail, I'd be happy to talk in a little bit more depth. But these are just, it's kind of just to give you an idea of the range of different projects that I've been a part of just in this last year. So it's really it's a wide scope of things that we do. So again, I've only been in this position a year, but some of my major takeaways just from federal contracting is that it's really crucial to be flexible and resilient. My coworker's favorite line, he can be a broken record, he'll say, if you don't like something about your job in federal contracting, just wait 5 minutes and it will probably change. Customers and funding and even the scope of the work that you're doing can change in an instant. And an important piece for me to remember is that federal contracts are subject to federal budgets. Also, a takeaway is that aviation meteorology is very small. I'm sure that people have told you that meteorology is small, but aviation feels smaller. Just this summer, I was in a conference, and it was called Friends and Partners of Aviation Weather, and I walked in and I could identify someone from undergrad, someone from each of my internships, from Southwest, and from grad school. It was kind of crazy, but it just is a really small field, so maintaining these positive customer relationships and a good reputation is really key. And then lastly, I've found that different backgrounds can come together and create really great perspective. I mean, just at AvMet alone, we have people with backgrounds in business and air traffic control, and even we have pilots and meteorologists and engineers all coming together. So I think that really broadens perspective, and it creates a really great mix of ideas and work ethics. And I think I expected everyone at a company called AvMet to all be aviation meteorologists. So it's really cool that they're not. So to close here, I really want to hammer home how important the UW-AOS program has been to me and how it helped me get here. So professionally, I mean, obviously, the subject matter expertise is a no-brainer with the coursework provided at UW, but the research experience has been especially valuable for me, and that has kind of really given me the curiosity to create my own research questions and to think about what can be researched for in my own career. It's also broadened my scope across the entire field, and then obviously it's given me the forecasting experience as well. But I would argue that even more importantly is the personal growth that UW-AOS program really helped me develop, and that's time management. I mean, you've all been in undergrad, you know how crazy schedules can be and how many different balls you're juggling at one time. So time management has been crucial. And then also self-motivation. I think that really comes with the research piece. And the ability to learn independently has been really honed in at UW as well. Leadership has been crucial, both with the chapter of AMS, which you're all obviously a part of, and then the Graduate Student Association in grad school was really helpful too. Flexibility, I think I mentioned that I came into college thinking I was going to broadcast meteorology, and my plan took 8 left turns ever since then. So I think just the flexibility that I learned in the UW program has been so crucial. And then obviously the lifelong friendships, both from undergrad classes and from grad school as well. It's been invaluable. So lastly, perhaps it's unsolicited, but I will leave you with a bit of professional and personal advice. Professionally speaking, the best thing that I would say to all of you is just to cast a really wide net and try your best to broaden the scope of your studies. I mean, the 3 bullets here are just my experience, and I'm sure all of you have your own experiences that you could put to this as well. But just from a research standpoint, I went from numerical weather prediction to remote sensing to wildfire convection. Course-wise, I went from the core classes to environmental studies to that EAP program in grad school, and then internships from broadcast to the public sector to the private sector. So as wide of a net as you can cast, I think is super helpful and beneficial for a career in any industry and in any field of meteorology. And then personally, I just would say to be really flexible, and this is both to location and to industry. I will admit I'm a homebody. I love Wisconsin. In my perfect world, I probably would have found a job in Wisconsin, but in a field this small, you kind of have to be flexible and willing to relocate. And I never would have guessed I'd be in DC, but I'm here and loving it. So flexibility is key for location, and then to industry, again, just that point that I thought I would be in front of a green screen, and I'm not. So just being flexible to different experiences in different parts of the meteorology field. And then lastly, I would just say to be open to asking for help. This is a really hard one for me to learn. I think especially in grad school, you can feel at times where you should know it all and you don't, and that feels like you're failing in a sense, but you're not. And every single person in the building that you'll encounter, and really in your career, if you stay in meteorology, was once an undergrad. So I think asking for help is probably the most crucial piece to learn and to get good at, I guess. So with that, I just wanted to thank you for your attention. And if anyone has any questions or wants to talk offline about any of this, I'm always available from email, and I'll leave this slide up and make sure that you guys have that as well.
Any questions or anything?
I have a question.
Yeah.
Yeah, go ahead.
So my question would be, what made you decide to move away from broadcast meteorology and explore like the private sector?
Yeah, that's a really good question. I'm sorry, I'm trying to get back to the screen where I can show you my face and not my, let's do this.
You're up there now.
Are you seeing me now? Okay. That's a good question. I think for me, and I don't want to project this.
Oh, that's weird.
Oh my goodness.
I think you just shared your.
There we go.
Yep.
Oh my gosh. I don't want to project this experience onto anyone else, because I know that everyone has their own experiences when they do internships like this. For me personally, I was working on the morning show, and I had just got done with sophomore year, which I think is like Calc 2 and 3, and it was Physics 1 and 2 and computer science, and I was feeling like I had all this knowledge and I wasn't putting it to the most optimal use in broadcast. And that it was humbling to learn, because I think that's something that I really hadn't set my sights on, but it was also important for me to know that I think I saw a statistic one time that broadcast meteorologists make up 10% of all meteorologists, but it feels sometimes like 90%, like everyone is on TV. So for me, it was the type of work that I was doing. I didn't love getting to the station at 3 a.m. Obviously, if you're an evening meteorologist, that would be different, but it just wasn't a fit for me personally. But I don't want anyone to think, oh no, I wanted to do broadcast and now I'm not going to. I mean, in my undergrad class, I think 3 or 4 of us are in broadcast now, so it's just different for everybody.
How many people in here are thinking of getting into meteorology, either for broadcast or like National Weather Service forecasting? Were any of you aware that aviation weather was a thing, or was something new to you that everybody's sort of shaking their head? I think the donuts have kicked in.
Or the really long, boring talk. I'm not kidding. But I think Pete brings up a good point too, that when I first came in, I wasn't even really aware of other industries, and now some of my classmates, I mean, we have a classmate in leading the energy sector as a meteorologist, and he's even kind of transitioned into a finance and business role. We have people in the private sector doing forecasting for utility companies. We have people doing forecasting for other areas of transportation. Schneider Electric is coming to mind, where they run a massive trucking operation, and one of my coworkers is doing that. Classmates, sorry. We have friends at at NSEP here in DC, people doing federal or public sector work too. So it's just really become a really nice spread if you look at our undergrad class of where everyone ended up. And one of our undergrad classmates is Pete. I'm not sure if you knew this about Will Hahn, but he is in the Marshall Islands in the middle of the Pacific doing forecasting for them. So he is doing a 2-year assignment, and if you drop a pin in the middle of the Pacific, that's where Will is. So just really cool opportunities are out there that I don't think people always know about.
Was he in Australia for a while, or has he always been in the Marshall Islands? Because somebody came on, we've been streaming Weather Watch on Fridays, and somebody came on, I thought it was from Australia, but it could have been the Marshall Islands. They came in on the end of their shift. It was like 10 o'clock at night there, and they were just chilling at home watching Weather Watch at noon on Friday here.
It might have been him, yeah. And one other plug that I think is really awesome to make in this scenario is I didn't know about this until, I don't even remember, maybe the end of grad school, but Penn State as a meteorology program maintains a really, really awesome job board. It ranges from like postdocs for people after their PhDs to entry level to internships. So I think Emma has that link, but if anyone wants to even just peruse around there, it's really awesome to kind of see. I think it gives you hope sometimes too to see how many jobs there are out there in meteorology.
I think we have a link to that and some other job boards too. I forget where it is on the website. We don't have a job board because it's just a real hassle to keep things up to date, but why redo it if other people have it going already? But I know we've got like a number, like there's an AMS job board, there's an AGU job board. I forget, there's like 4 or 5 of them out there that we've got links to.
Yeah, just things to be aware of. Even if you're nowhere near looking for jobs and that feels like it's a lifetime away, it's kind of fun just to look.
Any other
All right,
questions?
any other questions?
It's like everybody's happy.
All right. Thank you, Rebecca.
Thanks, Nick.
Yeah, thank you guys. It was a great semester.
All right.
Appreciate you talking.
Yeah, I'm going to sign off if that's all right,
That's cool. Thanks.
if I know how. Have a good one.
You too.